Okay, so I'll tell you what, we'll go ahead and get started, and then just wait to see when Brian and Andrea pop in. So I obviously I know Lisa and I know Holly, and I've met you, Sharon. We've met at AGU before,
Yeah,
been years ago.
yeah.
But yeah. So, but I mean, but I don't know, Sharon, if you want to introduce yourself again, and then we'll hear from Stephanie and Michelle, just so I can
Okay.
hear you all.
So my name is Sharon Chalet. I am working with the school called Hawaii Technology Academy at this point. It's a brand new school, charter school that is 100% PBL. And so the students spend all of their time working on projects rather than doing compartmentalized classroom direct instruction. They choose the projects that they want to be involved in, and we sort of guide them to make sure that they cover the different standards using the different projects that they're involved in. Last year was our first year, so this is our second year, and our students did better than their counterparts in the traditional school that's within the school district in terms of standardized testing and stuff. So we're pretty pleased with that first year, although it doesn't mean a whole lot for the first year. That's more of a baseline, but it was still nice to know that they did better. They at least were competitive. The students that I have are 7th through 12th graders. And there's two different sort of programs that they do. So one is a workplace-based program, and the other's a project-based program. But essentially, we're doing the same things, same kind of things. I have been involved in doing stuff like this with students for over 25 years, worked with the universities for probably about 15 years or so, doing it with undergraduates, teachers, and students. So I've had a little bit of experience with the different age groups on doing project-based and astronomy type programs. I used to run a planetarium and take it out to a portable planetarium that I take out to all the different schools and show teachers how to use the planetarium and run different programs with them, trying to get students involved. I had a group of students enter into the Google X Challenge last year, or a couple of years ago. I guess it was 3 years ago. And out of the 250 or so entries, they won 17th place, which was pretty cool. And they were 6th and 7th graders. So that was a pretty cool thing for them. I've been a part of, as I was saying, the Temple 9 mission, and with Tim Slater, or Tim Slater was a part of that, but a bunch of people from the IFA and whatnot. And so, yeah, I've been involved in astronomy for a little bit.
Okay.
A few years.
Okay, Michelle, go ahead. You're the one I see next.
Okay. I teach in the STEM program in our county, honors astronomy and earth and space missions. I've been doing it for 3 years. This will be my 4th year. My husband works at NASA. He actually works at Goddard in Greenbelt. And so I have access to a lot of scientists and engineers there because he can get me their emails. And I've had speakers come out to my school for the last 3 years, and virtual speakers last year, of course, with COVID. My students have participated in the International Observe the Moon Night in person at NASA, which is why I know Andrea Jones. And I haven't done any competitions with them. My calling was a math teacher. I actually teach math, but I got pulled into the STEM program about 4 years ago. So it's really exciting to me. I love astronomy. I'm very passionate. I'm willing to work hard, and I want students to have this opportunity. I found this and I was just amazed that it was out there, and I couldn't wait to apply and to go to it. So I'm excited.
Great. Well, we're glad to have you. Stephanie.
Hello. So I don't have nearly as strong of a background as what I've heard. I am very young, and as far as my teaching career goes, this is my second year teaching. I have a degree in geological sciences from the University at Buffalo. So this is definitely near and dear to me. This year, I teach 8th grade science. I also teach geometry. This year, I'm teaching a class that focuses on space exploration. We're actually in school right now, so if I'm mute a lot, it's because there's bells and stuff that I don't want you to get bombarded with. Arizona is very hot, so our school year shifted a little bit. So we start early, but we end, so they actually have a summer that they can somewhat enjoy. I know that I found this program really just looking into the resources we have here in this state, and I got some connections and just put out some feelers for ASU, and then this was kind of shown my way where they were like, hey, this would be a great opportunity, and I know that we're the only school in Arizona, I think, actively participating this year, so I think it'll be interesting to just bring something new to the table for my students and really just kind of show them that. And my real focus for space exploration is science doesn't just stop at the classroom. Like, there's so much more, and there's so many different areas that they could move into if they chose to decide to actually kind of take on a scientist mentality. A lot of my students will take biology and chemistry because they're required, and then won't take physics because they don't want to. And so they try to find like an easier science, but there's no such thing. So it's just kind of showing them like, no, there's everything comes together. And that's what I've been able to tie together so far for them is like, look, we're looking at the biology, we're looking at the chemistry, we're going to be looking at the physics. Like, this all goes together. Science is intertwined. So that's my mission. I want to make sure that I'm showing them the whole science world. So yeah.
Great. Well, planetary science is certainly a place to do that.
Right.
And actually, you're the only school from Arizona to have even apply, as far as I can remember, for this program.
Wow.
So, yeah. So
they have a good space grant over there, so they have other opportunities for teachers. I wish that I lived in that state.
I went to grad school at the University of Arizona. Worked on the Mars Phoenix mission while I was there as in the education program. So I spent a good amount of time in Arizona. Never went to the Grand Canyon. Did go to Meteor Crater. But yeah, no, actually, and on the Mars mission, we worked with Space Grant. We had a balloon. Worked with the high altitude balloon programming program. Students built, the little payloads to launch on balloons. That was something that we sponsored for, at least the 4 years I was there. So. Okay, and Jean joined us. You want to just introduce yourself to us?
Sure. I'm sorry I'm late. I thought it was 12 Eastern Standard Time.
No worries.
Okay. It's at 11 Central Time, so.
Yes.
All right.
Well, we started a little bit early. I'm sorry.
Okay. Because I'm usually an early bird. That's why I'm like, something's going on. Hi, everybody. I'm from Eastern Standard Time. I'm from Long Island, New York. This is my 22nd year as a teacher. I've moved up to the high school the last 3 years, which was interesting since the last 2 years have been a little bit different. I've taught earth science my whole time, my whole career, but I'm into science research right now. And I thought this would just be a great project for my students to kind of give them an earth science outlet, because it's really like biology heavy. So I'm looking forward to just being a part of this group.
Great. We're glad you're here. You're with Comac High School, right?
Yeah, I believe Rich Kurtz did this like a number of years ago. Not sure. He's retired now, enjoying his life.
Okay. Yes. And in fact, and Comac was a winner in 2017. So
Okay.
2016-17 school year was when their students went to Ames and presented. But I'll show you, I got a picture here, I'll show you in a second of,
Well,
they got some,
the poster is still hanging in the
Is it?
hallways. Yes, it is.
well, I would like to think they've also framed a picture of them, of the team with Harris and Schmidt.
I'll have to
I
check
will
it out.
send you that picture if they have not done that.
Okay.
So yeah, they got to meet Apollo 17 astronaut Harrison Schmitt, the only geologist to go to the moon. Well, at least for the formal geology training, I should say. But yeah, so they got to meet him and chat with him for a little bit. So I'm sure that was exciting. I missed that year because I was at home with a brand new baby boy. But I'm glad that they had a good time. And Olivia, I see you. Oh, thank you, Jean. Olivia, I see is also on. Welcome. Would you like to just introduce yourself to us?
Sure. I'm Olivia Cooper. I teach at North Green High School in Greenville, Tennessee. This is my second year at North Green teaching chemistry. And we just added a scientific research class, which this is going to fit right in perfectly. Before North Green, I taught for 16 years in Texas. I taught at Braswell High School and Lake Dallas High School, and also taught middle school, first grade, and fourth grade. So just run the gamut there with that. And I'm really looking forward to this program.
Great. Well, thank you. Glad you're here. Glad all of you are here. This is a time of year that always kind of excites me. Rest of the year is just kind of the same over and over every year. But I like getting this program off the ground and going. So two of our NASA folks are with us now, Brian Day and Molly Wasser. Brian, you want to say hi and just introduce yourself real quick?
Sure. Good morning or afternoon or whatever it is for you folks. My name is Brian Day, and I nominally work out of NASA Ames Research Center. I'm a Deputy Staff Scientist for NASA's Solar System Exploration Research Virtual Institute. That's way too long a name. But I'm going to show you today one of the tools that my team has developed that I hope will be of great use to you during the coming year. So good to meet you all, and actually good to see an old friend there too. Hello, Sharon. Good to see you
Hi.
again.
How you doing, Brian?
Good.
It's
good,
because
good.
of you that our students won in the Google X project or got the 17th place. So we really appreciate your support, as
Great
always.
All right.
Yes, Brian can use his powers for good sometimes, and that's a good example. Thanks, Brian. Hey, Molly, you want to introduce yourself?
Sure. Hi. Can you hear me all right?
Mm-hmm.
I'm Molly Wasser, and I am the digital media lead for the Solar System Exploration Division at NASA Goddard Space Flight Center. Also a lot of words, but basically my job is to talk to people in various ways about planets, the moon, our solar system. And I get to work with Brian and Angie a lot. And I know I recognize Michelle. Hello. And I'm going to be speaking with you a bit later about a program that we run, International Observe the Moon Night.
Great. Thanks, Molly. And Brian, before I forget, I just want to mention that I'm thinking of revamping, not redoing, but revamping our Moon 101 activity to be centered around Moon Trek. So I want to talk to you about that at some point, not today, not here, but I wanted to just put that bug in your ear.
Very good. Look forward to the conversation.
Great. And possibly having Goddard involved, just possibly include some of their stuff too. So I'll probably be getting a hold of you too, Molly. All right. Well, thank you all for joining me today. I would definitely want to keep this to an hour, so we can just keep moving, or let you go on with your day. So right now, I just want to share with you the homepage to the ExMASS program. I apologize for the very 90s looking web page, but sometimes you just can't convince some folks to change. Brian knows who I'm talking about.
Cold inertia.
So just want to, this gives you a little overview of the program, which I'm sure you will understand by now. So we're offering, it offers high school students, secondary students a chance to do authentic inquiry-based research with assistance from a scientist advisor. In some ways, there's nothing too particularly unique about our program. But I guess it depends on who you talk to. Although it is a program and there aren't a whole lot out there. So anyway, we're funded by the Survey Institute that Brian works for and gave you the ridiculously long name for it. I am part of what's called the Center for Lunar Science and Exploration. It's one of the Survey teams that we're headquartered, or the CLSC team is based out of the Lunar and Planetary Institute in Houston, where I work, but it works alongside the Johnson Space Center, the Astromaterials group there. So Astromaterials, they're the group that houses and maintains and curates all the Apollo samples, the meteorites collected in Antarctica. They'll be curating the OSIRIS-REx samples when they come back. OSIRIS-REx came up a little bit earlier, so that's that group at Johnson Space Center. I like to show this. It's just kind of fun. This is a map I created that shows all the. This is a huge file that shows all the places on the moon where students have studied, or locations that were the focus of student studies during at least the first part of our program. I need to update this to include last year's stuff, but that's just a. Oh, come on, this thing's in my way. It's all right. I just like to show that. I need to put together some kind of graph visualization about asteroid stuff, but I'll work on that. So our 3 program goals, as I said, we want to just provide an opportunity for students to engage in multiple practices of science. So, not so much what's been called an apprenticeship model, where, a student may go work in a scientist's lab for a summer and just help collect data, but it's not their study, right? It's the scientist study that they're assisting with, and that's great. There's nothing wrong with that. But we're trying to do something different where we give them full ownership of what they do, but with assistance from the scientist. We want to foster positive attitudes towards science. We actually have a paper that was published 3 years ago showing that we do that. Statistically significant differences in pre and post attitude towards science scores, at least on this particular survey we've created. So that was exciting to have that. And we actually have a study going on right now with researchers, education researchers at the University of Houston, Clear Lake. They are looking at the relationship between scientists and the students and trying to characterize that relationship and find out, what are some things, what are some characteristics that really make it work, and maybe what are things that we should avoid. It's a study I've been wanting to have done for a long time with this program, but it's just not within the scope of my evaluation of the program. So it was great when these professors were like, "Hey, we have students. We need a topic." That rarely happens with grad students. So they're doing that right now. In fact, they presented some early results at the Survey Forum a few weeks ago, and that'll be a continuing study. And then we want them, of course, to enhance their lunar and asteroid science content knowledge. We recognize that a lot of students coming into this program might have talked about phases and might still remember why we have phases, lunar phases, and maybe even something about tides. But if they're going to do research about the moon or asteroids, they kind of need to know a little bit about them before they start. So we certainly hope we do that. And some of the results we have from their pre and post surveys on content shows that they do, which, I mean, it just stands to reason they would learn something. And we've got our map we have every year. So we got all our teams for this year all up there. So you can point people to this and say, yes, look, we really are participating. And actually on that note, a couple of you have asked for press releases. So we sent a couple of out to some folks. So if you would like one, or if you'd like us to send one to a local newspaper or just to your school or whatever, just let me know. It's very simple. We can do that. Down here towards the bottom of the homepage are places is a place you're gonna want to be familiar with. We have an FAQ there. I still have the schedule from last year. I need to update that. But it's just a basic outline of deadlines and things for over the course of the program for this year. I'll just mention that a lot of the deadlines you'll see on there aren't really hard. They're fairly flexible. But there are a few, especially when we get towards the end of the year, that are pretty hard deadlines, because those will coincide with when abstracts are due for the survey form in the summer. But that's not till next spring. We'll worry about it later. Here's where you'll find the links to Moon 101 and Asteroid 101 activities. In my initial emails to you all earlier this summer or late last spring, I had suggested if you could, to go through those yourself. So when your students participate, you have a better idea of what's going on. You can help them easier. If you didn't, that's fine. Don't worry about it. I'm here to help you too. If any questions come up that you're not really sure how to answer them. We have a link to various lunar and asteroid data resources that are available. This certainly is not comprehensive of what's out there. There could be stuff available that I just don't know about, to be honest, but it's certainly accessible by anybody. There's also lots of data out there that's not very accessible, but that's one thing Brian's hoping to change with the Trek stuff. So you will probably run into that situation, particularly if you're going to be looking at asteroids and anything other than geology. You might have that problem. So your advisor will certainly be able to help you overcome that, help you get data. And who knows, maybe even Brian may even have a recommendation for you. So when this program was preceded from 2010 to 2013 by it started with just lunar research, and it looks similar, but also looks different today than what it did initially. But when we started the ExMASS program, as we call it today, before that first year, we had invited some teachers from the past, including Lisa, I believe, and some advisors from the past. And they came out to LPI one weekend, and we just talked about this program and what are things we need to do to improve it from a teacher and from the scientist perspective. There's a great conversation. And one of the things that came out of that was how we identify people who participate in the program. So obviously there's the students. They all decide that as the scientist, advisor is the best word to use for that. And for teachers, mentor is a good word to use to describe them. So anything you see with our program regarding mentors and advisors, mentors means teachers, and advisors are the scientists that are paired with the teams. So that particular page just goes into that a little more about what kind of what's expected of the advisor versus what's expected of a teacher. And those are things, and that page and some documents within there, I update at the end of every year based on feedback from the surveys that I hand out or distribute. So I update that when I can. Other resources are just like clips to videos or links to videos and exploration documents NASA's put out or the National Academies has put out, things that might be of use to you as you're going through and trying to decide what you want to do. And one thing I could suggest is, and this may be outdated, Brian, you can correct me on this. If you decide you want to do some kind of lunar project, but not really sure where to start, there's a document linked to in there. It's the scientific context for exploration of the moon. And you could go look and see what the objectives are, the science objectives for exploring the moon, and that could help you possibly narrow down a topic you might want to pursue, your students might want to pursue. So that's just an example of something in there that you can look. Brian, is that still pretty much kind of the go-to source for that kind of thing, or is there something more updated?
Yeah, that's still very good. Also, the results from our landed lunar missions workshop.
Yes.
And keep your eyes open because a new decadal from the Planetary Science Division is due out soon. It is being worked on. And so that's where we'll really see the new stuff. But for now, yeah, those are good sources to work from.
Okay.
But look forward to the new decadal coming out in the coming months.
Great. And I will make a note. I'll make a note of that, of the landing site workshop, and post a link to those findings, and also the Artemis science definition. So science definition, scientists got together to come up with objectives, scientific objectives for the Artemis missions coming up. So that could also be a potential place to look at, to look for possible topics. So the big thing within having an advisor, at least in the role that we have them in, is that they will be able to help your students narrow down their research topic to make sure that they're doing something that, isn't just a literature review. It'll take a few weeks or a few months to do, but also making sure they don't try to do something that's going to take 2 years to do, or do something that requires instrumentation they don't have. I'm guessing your schools don't have scanning electron microscopes. I'm guessing they don't have a transmission electron microscope. Or a mass spectrometer. Those kind of things, hard to come by when you're a high school student, hard to get access to. So they really help with that, narrowing down that topic to get something just right. We have an archive of past presentations. Unfortunately, right now, they go to broken links, but I
noticed that.
Yeah,
I noticed that.
Those were recorded on Adobe Connect that we had used in the first 4 years of the program that Survey provided us an account with. Well, they've stopped using it, but they've gone through and they've been able to pull some of those recordings out and post them to YouTube. So once I get our recordings, we'll be able to fix that. So I apologize for that. Okay. Anybody have any questions so far?
I guess my question is, in the initial content, it says for mentor role, the content expert has to conduct the Moon and Asteroid 101. So do I need to go through and read all the materials and answer all the questions? Like, I don't know if there's a key there. Is that something that I need to do?
So I know with Moon 101, we did have a teacher guide, and I think that has kind of like in general what the answers might be. So you can, or you can just do it right along with the students. However you want to do that. But like I said, certainly feel free to ask me any questions you might have. So here's the Moon 101 page. There's a student guide, the teacher's guide. This was done 12 years ago when we first started the program. So I try to keep it updated as much as I can. Yeah, so there it is. Again, any questions, just let me know if you have them. Anything else for now? Okay, I want to show you one more thing here. This is just a thing I submitted to Survey at the end of the 4th year of the first round of our ExMASS program. So there's been different rounds because there basically was a gap in the funding, just because the way the funding cycle worked out versus the cycle for our program, they just didn't mesh. So there was a gap between the programs, but no big deal. That gave us some time to catch our breath and make some updates. So if you include our pilot program, what I now think of as our pilot program a decade ago, over 500 US students have participated in this program. That actually number doesn't include last year's. We so I guess this is as of 2018. So 33 student posters have been displayed at the forum, and about 20% of these were recognized with an award. So whether it's honorable mention, posters have gone. We've had student posters get as high as 2nd place in this competition. Although we're seeing more student posters than in the past, so it's getting a little competition is getting stiffer out there. We did have one student research be published in the journal Icarus. That has certainly been an exception. It's not the rule. It doesn't. What your students do does not have to be published. In fact, more than likely, whatever they're able to get done in the time they have, it wouldn't most likely be ready to be published. And in this case, the advisor just really loved what they did and thought it was great and needed to be published. So she worked with them for a few more months, or maybe even almost another year, to take a little bit more data, do a little bit more analysis to really get it ready to be submitted for publication. So that was just something the advisor really wanted to do. So that was great. I wasn't going to say no to that. That same project was highlighted or was featured in the journal Science the month before it actually came out. Student project was highlighted in an ArcGIS users magazine called ArcUser. That was actually the Comac school, high school, I believe, from a few years ago. And one team was invited to present the research at the International Science and Engineering Fair that they did for us. So our evaluation data shows that we're meeting our goals. We're doing good, but we can always improve, of course, and we're always looking for ways to do that. I think if I can move Moon 101 to Moontrax, I think that would be really cool and very modern. And there's a citation there for that paper that we wrote if you're interested. So there's the picture there of the Comac High School kids from 2017 Exploration Science Forum with Harrison Schmidt. So I bet my understanding was they had a really great conversation with him. He was pretty interested in what it was they did. So that was exciting. You never know who you're going to run into at the Exploration Science Forum. So.
Andy?
Yeah.
Oh, sorry, I wasn't able to see the picture that you were talking about.
Oh, okay.
Yeah, I didn't see it either.
Yeah, we were stuck on the webpage still.
Oh, really? Oh,
Yeah.
geez.
Oh, here.
Okay.
Whatever you just did.
Gosh. Well, okay. Let's talk about this all over again. No, I'm not going to do that to you. Okay, do you see that now?
Mhm.
Yes.
Okay, I'm sorry. So there's that map there shows you where all the locations of all the schools up to 2018. And then there's the picture with Harrison Schmidt. So, okay, I'm going to stop sharing. And Brian, I'm going to let you give us your spiel.
You're on mute.
Okay, I'm going to attempt to share my Moontrek portal with you. So with any luck right now, you folks are seeing the moon.
Yep.
Are you in fact? Good, okay. So Moontrek is a data visualization and analysis portal that is currently being used for site selection and analysis, as well as traverse planning in our upcoming missions of the moon. And we have a version of it available for the general public. And that's what I would like to show you right now. Think of it as a GIS system for the moon. So we can, like any good GIS, you can zoom, you can pan. And what we'll do right now is we'll zoom down to, this is an area called Locus Mortis. This is an area you're going to be hearing a lot about because we're planning to actually have a landing there next year. So ideally during this coming school year. This is a very interesting area. You can see it has a large crater Berg here, a number of fractures on the floor. And one of the things you might want to know right away is, well, gee, how big is that crater? That's actually fairly easy to determine. Distance measuring is as simple as drawing a line. So we can draw a line from one side of the crater to the other. And with any luck, there we go. We can see it's 41 kilometers across. So that's a pretty big hole in the ground. Another thing you might want to know is, well, how deep is it? And similarly, that's also very easy to determine. Again, we'll draw a line. This time we'll extend it on either side of the crater so that we catch the rim. And here we get an elevation profile. So it's easy to measure the heights of mountains, the depths of valleys and craters. There are a few other very useful tools. We can draw a bounding box around any feature, and you get a choice of generating an STL or an OBJ file. If you can see my camera here, I'm holding up, you can generate files for 3D printing. This is a 3D print I made using this process of the lunar South Pole. But that's very popular. And I'll show you one more example. You can draw a path anywhere you want. And it will generate a QR code. Scan the QR code into your smartphone, put your smartphone in a pair of cheap Google Cardboard goggles, you know, $5, $10 goggles, and whatever path you drew, you will now fly in virtual reality. The real power of the, well, there's one more thing I'll show you. There are different ways to view the data. So we can switch into, for instance, a 3D global view. And I'm not sure how well this is going to stream across Zoom here, but we'll give it a try. But as you can see here, you can interactively go flying across the surface of the moon, create your own traverse paths, fly across and explore areas. The real value, though, we're switched to another projection here. Let's do a polar projection. Here's the south pole of the moon. And what we have available are thousands and thousands of data products taken through various instruments aboard various spacecraft. So different ways of viewing the surface of the moon. These are georeferenced, co-registered. And so what I've done is I've loaded up a few examples. So we have here the LROC camera view of the south pole of the moon. And you can see a lot of deep shadows. We can pierce those shadows by loading a laser altimetry view. Here's a slope map. We can overlay permanently shadowed areas where the sunlight hasn't shone in over 1 billion years. We can look at temperature. Here's average temperature. We can see maximum temperature. We can look for signatures of hydrogen, which give us clues as to the location of water. This is neutron spectrometry data, and even maps of ice stability at depth. How low would you have to dig to be able to find ice at a stable temperature? So do one more example here. We'll go back to our global map and let me zoom out. And what we can do is we can fly to a particular area. So we can just type in either a latitude, a longitude, or location by name. And we'll go to the crater Marius. And around Marius, we have one of the most spectacular concentrations of volcanic peaks on the moon. It doesn't look so spectacular here, though. But we can, again, let's do a, let's add a laser altimetry view, and all of a sudden those peaks jump out. We can stack different layers. So I'll do another search here. We'll do a gravity map. And we'll add that. So now we see a completely different view of that same area. But one of the things we can do is we add layers. You can, again, stack them like cards in a deck, reorder them, and you can adjust transparency between them, blending them. So here now we get a combination of gravity data as well as altimetry, laser altimetry. And that allows us to see the surface morphology of the volcanic complex here, as well as now with this color coding, with red being higher gravity, blue being low, we can now visualize the now solidified unerupted plug of magma beneath the volcanic complex. So you can take different data products from different instruments and blend them together in unique ways. This gives you a lot of opportunity to conduct your own unique explorations of the moon. So I'll just mention one more thing is that, again, we have some far more sophisticated tools that are used for mission planning and general planetary science. We typically don't make those available to the general public, but in your case, if your group decides that you need them, we can make them available to you. This is all part of NASA's Solar System Treks site. This is, you can see here, this was the Moon Trek portal, but in terms of your asteroid studies, we have similar portals for the asteroid Bennu, Ceres, Ryugu, and Vesta. So with that, I'll shut up.
Thanks, Brian. So if you were watching that and you felt kind of overwhelmed by it, that's okay. That's okay. It'll be a process. You learn more about this stuff as your students are going along. Should they decide to do a lunar project, you know, Moon Trek is great. It's a very powerful thing, and like even Brian just said, there's even more to it that's just not readily available to the public. Brian, you want to mention the little offshoot that you're doing with the Mount Horeb High School students with Pascal?
Yeah, so we actually have an experienced ExMASS team that is working with scientist Pascal Lee out of the SETI Institute. And he's got some areas of particular interest kind of toward the North Pole of the moon, where he believes there could be actual skylights into lava tubes. And these could conceivably be areas where ice might be sequestered down in these lava tubes. And so the students are going to be working to actually look at landing sites as well as traverse paths that might provide accessibility to those skylights.
Yeah, so I am not going to be interfering, so to speak, with that project over the school year, but I'm going to be keeping an eye on it, talking to Brian and Pascal, and talking to the teacher from Mount Horeb, just to see kind of how it's going as a team who's had experience in our program and then going on and doing something like this. And if it works out pretty well, maybe it's something we can do in the future. So perhaps next year, if your team, your students who participate this year might be interested in doing something like this next year, if somebody has a project like Pascal has something like this right now, you might be able to do something like that. We'll just see. You know, a lot of things have to fall in place, of course, at the right place at the right time. But something that we're exploring. Does anybody have any questions for Brian?
So years ago when my students did this, we used the tool, the JMARS tool for the moon. How does I mean, I know there's been a lot more data collected and sort of stacked in places, but from an ease standpoint, does the Trek site operate pretty much the same sort of way?
Similar. The JMARS type tools were based on Java applications that you would download to your computer. These are all completely browser based. So you don't install anything. You just point your preferably Chrome browser to our website and you can go exploring as you wish. And one of the things that we allow too is any of the data products that you're exploring, we make it easy for you to be able to download those data products. So if you've got some other tool that you want to use, locally, that's fine. You can think of this as being a way to find and access and download a wide variety of data products.
Thanks.
And I guess I had a question. Are we going to need to explore the treks, like to learn how to do it ourselves? There's like a tutorial or something. I was just
So that's a really good point. When you first enter one of the portals, you will get a little box that will come up and ask you if you want to take a guided tour. And in general, the answer will be yes, because that will then walk you through all the various controls that I breezed through oh so quickly right now. So there is essentially a built-in tutorial for each of the portals.
If they did a
And
tutorial,
if you have any questions, please do feel free to contact me. Andy will give you my contact information, and we'll make sure that you are comfortable using the tools.
Brian, if when it works, he can possibly even give you, talk to your students. We can have a session with him and go over stuff.
Be happy to do that.
Okay. Any other questions for Brian? All right. Well, thank you, Brian. Appreciate it.
Thank you.
Okay, Molly, you want to talk to us about International Observe the Moon Night?
Sure. So before I begin, has anyone here heard of International Observe the Moon Night? Okay.
Yes.
Awesome. I see some hands. And how many, again, hand raise, how many people have participated in International Observe the Moon Night? Awesome. Okay. So for those of you who haven't, International Observe the Moon Night is a global public celebration of our moon. It happens a day in the fall. The day changes based on the moon phases. So we always try to have International Observe the Moon Night around a first quarter moon, because a first quarter moon rises, it's up high in the sky in the late afternoon, early evening, which is really ideal for observing. And as Brian can attest to, the line between night and day on the moon, we call that the terminator. That makes for really beautiful observing. The shadows emphasize craters and mountains and features. So this year, International Observe the Moon Night is October 16th. Mark your calendars. But we are a little flexible with the date. So if that day doesn't work for you, you can celebrate around then. I do have a few slides I'd like to share, which I just have a tab open. So I might just, let me see if I can share my screen.
Not in person, is it, this year?
No. So in the years past, International Observe the Moon Night has really been about encouraging events and in-person events. So at Goddard, we always had an event, which Michelle and her students have participated in many times. But obviously with the pandemic, that is not an option. So, or it is, at least for many people, it's not. So last year, we switched gears a bit, and we've been encouraging virtual events and also observing from home. So that's what I'd like to share with you. Okay. You're going to see yourself for a second because I'm on a NASA computer. I don't have Zoom, the application. So apologies for that. So you should see a slide with some pictures. So International Observe the Moon Night, we interpret observe very broadly in how you celebrate. The point is to just think about the moon, look at the moon, and there's so many different ways that you can do that. So here, this girl is in India, and she is observing the moon outside. You can also explore the moon with Moon Trek, as we just saw. You can look at lunar images from space telescopes. You can feel the moon. Here we have some 3D prints, and we have 3D print files. And then here's on the right is an activity that Andy took this picture, actually, where students and I think kids, Andy, you can speak better about this, but it's an activity where you make impact craters with paint. So I'm going to share our website. So our website is moon.nasa.gov/observe, and it has all the information you could need about International Observe the Moon Night. If you'd like to host an event in person or virtual, if you'd like to do something with your students to celebrate the moon on October 16th, if you'd like to offer them, we have recommended activities, and it's really wonderful because it's as you're celebrating the moon in your own way, you can know that people all around the world are celebrating with you. So last year we had events in all 7 continents, including Antarctica. Andy, thank you very much. Got a connection. There was an event at the South Pole celebrating the moon. You can see here some observers looking at the moon. We also had people created lunar artwork, all sorts of things. And my final, before I take up too much more time, my final request to you is that if you celebrate Observe the Moon, we ask that you register on our website so you can register an event for the public, which means that people can come to your event. It advertises your event. You can also register a private or a household event. So like my parents observe the moon and they register, they had some friends over and registered this way. And so a private event is not advertised. And then, or you can just register as an individual participant, say, hey, I looked at the moon today. And by registering, you can get an exclusive image of the moon from our Lunar Reconnaissance Orbiter spacecraft. And you also will stay connected with us to get more information about this event. And then finally, if you'd rather not host an event, but you want to attend an event, either virtually, you can go to participate. There's all different things for you to do, but find an event. So sorry, are you still seeing my screen? Just checking. Oh, no, I'm so sorry. Okay. Can you see it now?
Yes.
Okay, sorry.
No.
Thank you.
Yes.
Okay. Yeah. You can find an event. So you can see what date you're available. If you'd like to have a virtual event or attend a virtual event, an in-person event, or a hybrid event, we have those options. And then you can look and see what events are available to you. So we just opened registration last week. So we have a few events here on our map. There's only 4 events registered for the public so far in the US, but that number will go up a lot. And I'm going to stop sharing now and see if there are any questions, and or if Andy and Brian have anything they'd like to add.
No, I have nothing to add. We'll say this year we're in the midst of planning a virtual 1-hour event on NASA TV, and also through the NASA social media channels. We stream live through those too. We had one last year. It was a very off the cuff, last minute thing that was 6 hours long. We learned right away, do not do a 6-hour virtual event. So we're cutting it back to 1 hour this year. So you can look for that too. By the way, no, thank you, Molly. Brian, anything? Oh, Brian, moon map.
Yeah, I
Oh,
was going to ask Brian to talk about that. But
so yes, there is a map that you can download, or actually a set of maps that you can download for the your observing pleasure for that night. They focus on the various seas of the moon, on the various Apollo landing sites, and we'll have all of those in view this coming Observe the Moon night, as well as some specific telescopic treats for you to enjoy, things that will be of particular interest. So those will hopefully be of assistance to you as you observe the moon. Thank you, and just thanks to Molly for all the outstanding work that she does on this program. It is really a fantastic way of engaging the public in looking at our nearest celestial neighbor.
Okay.
and I'll put all those links in the chat.
Hey, any questions for Molly or for Brian?
Yeah, I'll just throw something out. So if you don't like, I'm in the middle of Alabama, which is not really that close to Huntsville. So there's not really great, like, big resources for the International Observe the Moon, but I've contacted we actually have like a local astronomy group, which is just a handful of people, but they're always super excited to bring their telescopes outside and have kids look through them. So if you live in an area where you might have a local group, that, they love to be able to let people look through their scopes. So if it's safe.
Yes, that's a fantastic thing to do. Something I love about Observe the Moon Night is that no matter where you are, you can see it. So I grew up in Philadelphia, which there's a lot of light pollution, but I couldn't see planetary nebula, but I could see the moon. So it's a great stepping stone to begin that journey of observation and looking up.
If you are going to plan a Observe the Moon Night activity for the public, one resource that is really potentially of great value to, and it ties in with what I think it was, Lisa, you were just saying, was the working with your local amateur astronomy groups. And fortunately, NASA has a network of amateur astronomy clubs, the NASA Night Sky Network. And if you Google NASA Night Sky Network, you can see a long list of these astronomy clubs, and these can be outstanding partners as you plan events.
Yes, that's a great resource.
I just dropped the link to that as well in the chat.
Okay, any other questions about moon treks or International Observe the Moon Night? Or any other comments?
I just want it to be physical again when it's safe, because my students had the best time doing them, participating.
Yeah, I've been trying to figure out how to plan it and what the situation's going to be and get in touch with people, but so far the local clubs aren't meeting, and Science Works hasn't done anything, and yeah, I have to wait and see.
Yeah, it's really, it's definitely a challenge. This year we decided, instead of having trying to wait and see if we could have an in-person event to focus on a virtual event. So that's also why Andy and I have really been investing time in a TV broadcast. But we've really put a lot more resources on the website to encourage observing from home. So it's not as much fun, but
Can I
it's
ask
still
you
a
a
way to
question?
connect. Mhm.
My students have painted the moon in the past and hung their paintings at NASA.
Yes.
What if, I mean, would there be any way for them to be able to paint the moon and then share their paintings through the, I mean, I think your thing is only an hour, so I don't know how it would work, like virtually.
That's a great question. We do have a gallery, a Flickr gallery, where we've been encouraging people to upload their lunar artwork. So if your students did that, we could have it be on the Flickr page, and then we could feature some of those on our website as well.
Okay. Can I email you, I guess, more?
Yes. Yeah, and I know you talked to Stacy Tiedekin.
Yeah.
So Stacy actually has, yes. So Stacy's actually the lead of that lunar artwork facet of the program. So I'm sure if you connect with her, she'd be delighted to provide more information.
Okay. Cool. Thanks.
So Molly and Brian, if you two don't mind, I'll share your email addresses with everybody so they can contact you for various questions if they have them.
Sure, please do.
Sounds good.
Great, thank you. So we're almost out of time, but just a couple more reminders that I want to put out there. So when we get done here, we're pretty much kicked off, ready to go. So when your students come back to school, if they're not already, you can start the 101 activities. By middle to end of October, and they can go sooner than that if they're ready before that. What I like to see is, and this is in the guides and everything, a presentation from them where you'll see them on the website in the Moon 101, Asteroid 101 pages. Just 3 images for the moon and 3 for asteroids. And what I want them to do is just use PowerPoint or Google Slides, whatever, just present a geologic characterization of the images they see. So what kind of geology do they see in those pictures? What are the features? How do they form? How old are they relative to one another? The idea is to take what they've learned from the 101 readings and just chat. Tell me about the geology they see. In the past, students have included things about like lunar formation ideas. They don't need to do that. They tried to kind of include everything they did in Moon 101, but that's not what I'm asking for. They don't need to do that much stuff. Just simply those 3 images. Talk to me about the geology they see. There'll be a little bit of a Q&A with it. If they say something that is really off or completely opposite of what's reality, whatever, I'll give them some corrections, but that doesn't happen too often. They do very well. They do pretty well with this, and then plus it gives them a chance to talk about something they probably have never talked about before, so they can kind of help with get rid of some butterflies possibly, or get some nervousness with doing this kind of thing. So mid in October is when I look for those. Again, if you're ready beforehand, that's fine. I saw in the chat somebody's kids don't come back until next month, and that's fine. If you need a little more time, like the 1st November, that's fine too. This is one of those kind of soft deadlines. I'd rather they take the time to get through this and understand than rush through it just to get it done. So that I will be sending around a couple of different release forms. So one is for each student. So just a release form that says, yeah, you can share their picture or their likeness from a video like this online. Just a thing for parents to sign saying, yes, we do allow, or we won't. There's both options. And then another one, so one for each student. And then there is a form that just the whole team and the teacher signs. It's kind of an informal, but a thing we like to have that just says, you're okay with us posting your research. So we will have recordings of the 101 presentations and then research recordings. And then we like to post a picture too, or their poster online also when they have that done at the end of the year. So this is just a form that says, yeah, it's cool. You can put our stuff online for people to see. There's a question here about 101 stuff. Yes. So students should complete both 101 activities. Yeah, should do
Okay.
both.
Okay.
So I think one time in the past, what we did is if students come in knowing that we're going to do asteroids, then I'd kind of be okay with them only doing the asteroid one. But I don't think anybody really does that. Knows for sure coming in which one they want to do. But no, it'd be great if they could do both. They could split it up, right? Like half could do one, half could do the other, and then they just talk to each other and teach each other. So something, however you want to do, that's fine. We're not going to tell you how to do that or how you should form your teams. How you want to do that. That's totally up to you. Oh, and on that, if you are going to have like two different teams or cohorts or whatever of students working on two different projects, that's fine. But we will only be able to give you one advisor. So you'll have to use that time wisely or or efficiently and make sure you're not overburdening your advisor with stuff as much as possible. And speaking of advisors, I just need a couple more. I'm doing pretty good. Doing pretty good at this point in the year. I already have 7 advisors, so I'll just need to reach out and get a few more. So and when I assign advisors, I do my best to at least get you in the same time zone. May not necessarily be in the same state, but I do try to get to where it's be easy in terms of, setting up meetings for that. So, all right, we are at the top of the hour. As I said, I'm recording this. Well, I'll post it to YouTube, so it'll be available for you to go back and watch it if you want to. Any final questions or comments for me or Brian or Molly?
So are you personally going to be listening to the students presenting the information that they learn, or are we going to be posting the PowerPoints online? I'm a little confused about who's actually going to be seeing those other than myself and the students in the class, in the team.
Okay, yes, good question. So for the 101 presentations, yes, they will be presenting to me.
Okay.
Yeah, and I don't typically invite other people to participate in that. It's just usually me and the students.
Okay. I don't know about everybody else, but I will tell you that I'm going to need credentials from you if you're going to be interacting directly with the students virtually. I just have to tell you that because my school system requires a background check through our system. And that's going to be true for the mentor as well. I don't know whether it's true for any of you guys, but that's just something that we implemented last year when we had the virtual school.
Yeah. Okay. Interesting. No. Okay. Well, I'm sure there's lots of firsts like that. That's just the first time I've come across that. I don't imagine that'll be a problem.
Right. I don't think so. Just driver's license, and then I just put it through. Nobody's had any issues with it. It's just I just have to let you know that it's not something I'm not trying to get personal information from you, but in order for my county to approve you to interact with students, you have to provide that.
Okay, so I guess I'll need to then also for that. Okay.
Yes.
Yeah, no problem.
Sorry.
And Brian would too then if you wind up having him chat to your classes.
It's probably just a good idea to get it from everybody because then it would not have I wouldn't have to wait on anything.
Right.
But yeah.
So then I'm sorry, this is just another example. So like at the end of the year, if you're one of the top 4 posters and you're all those 4 posters, those 4 groups come together, then like any adult who's part of that, who's part of viewing those would need to do it.
It's not necessarily them viewing. It's if the students log into the conference virtually, that's not a problem because they're logging in themselves. It's if you join me on a Google Meet with the kids through the school system.
Okay. Okay. Well, then we'll let you just let us know when it's necessary.
Okay, I'm sorry to bring it up. It's just something that's
No, it's
part of-
important. It's no, that's good to know. It's a need to know.
want to let you know.
Yes, thank you. Well, no, yeah, and then just let us know as
Absolutely.
as needed.
Absolutely.
All right. And I see from the chat box, looks like most of you would like a press release. And to be honest, it's the same one. It's kind of generic. So I'll just send one out to everybody. That way you've all got it. If you would rather, though, we send it to somebody specific at a newspaper or something, then yeah, let me know that and we'll send it to them. All right. Well, thank you all so much.
Andy?
Yeah.
I'm sorry to interrupt. When we talked at the conference, you talked about you had something that you could print up and kind of like I could hand out to parents, like a brochure or an information thing.
Oh, well,
that'd be like the press release kind of.
Well, no, so I don't have like a brochure for the program. We don't have anything to promote it other than the website. Okay. The press release is actually just a thing saying that, okay, there's this program. Here's the school, schools from these states have been selected, and the name of the school and the state have been selected, kind of a thing. That's all it is. It's pretty basic.
Okay, so I can make something up then.
Yeah, that slide I showed that had the picture, would that be something?
That's a good one, yeah.
Okay, I can send you that as a PDF. Yeah.
They can say, "Oh, wow, look at us, we're in Medford." Okay.
Andy, can you send that to everybody?
Oh, sure. Yeah.
Yeah. Yeah.
All right. Okay. Well, thank you all again so much. We're a little over, but I think that's okay.